All right, this is the next lesson in the unit called rational functions. This lesson is called multiplying and dividing rational expressions. Okay. So you can multiply rational expressions the same way that you multiply fractions. Okay. Now these are the steps that we're going to follow when we multiply rational expressions. Step one, you have to factor all the numerators and denominators completely. Then step two, you're going to divide out the common factors of the numerators and denominators. Okay. And after you do that, you multiply the numerators and you multiply the denominators. Okay. And make sure that the numerator and the denominator have no common factors other than 1. Okay. So example 1, multiply, state all restrictions for the variable. Okay, so what we have to do is we have to factor. Okay. The numerator in the top left, x plus 1, you cannot factor that. I'm going to leave that as x plus 1. The denominator in the bottom left has a common factor of 3, the GCF of 3. So factor out the GCF of 3, and it leaves you with x plus 2 in parentheses. The numerator in the top right has a GCF of 6. So factor out the GCF of 6, and it leaves you with x plus 2 in parentheses. And the denominator in the bottom right, that is the difference of 2 squares. So in case you forgot what that was, I think we did that in the first lesson. Here we go. Difference of 2 squares. Just to refresh your memory, a squared minus b squared equals a plus b times a minus b. So x squared minus 1, that's the difference of 2 squares. That factors to become x plus 1 times x minus 1. And now we're going to divide out the common factors. This x plus 1 divides out with this x plus 1. This x plus 2 divides out with that x plus 2. I'll take care of the 6 and the 3 in a minute, but we have 6 over 3 times x minus 1. And now 6 over 3, of course, becomes 2. So 2 over x minus 1. Then you have to do the restrictions. X cannot be negative 2. Don't forget about the factors you divided out. X cannot be negative 2. X cannot be negative 1. X cannot be 1. Let me just jot down a little note right here in case you forgot from the first lesson. Don't forget the restrictions. The denominator cannot be 0. So don't forget the restrictions, and don't forget about the factors that were divided out from the denominator. Okay. So what I mean by that is don't forget about the restriction for x plus 2. Even though it was divided out, you still have to put that restriction. And even though the x plus 1 was divided out, you still have to worry about that description, about that restriction. Okay. All right, on to example 2. I'll go a little faster this time. I have 5 examples total today. Okay. So For this one, the hard one to factor is the top left. So let's focus on the other ones first. The bottom the bottom left, x minus 4, you cannot factor that. That stays. The top right, that's the difference of two squares. X squared minus 16 factors to become x plus 4 times x minus 4. The bottom right, it's a trinomial and it's a quadratic with a leading coefficient of 1. So when it's 1x squared, those are the fast factoring problems. What two numbers multiply to 15 and add to 8? X plus 5 times x plus 3. Okay, so the hard part of this problem is the top left, factoring the top left. So let's do that off to the side. First thing you're going to do when you factor 2x squared plus 7x plus 3, remember, is you're going to do 2 times 3 is 6. Now you need two numbers that multiply to that 6 and add to the 7 in the middle. Two numbers that multiply to 6 and add to 7. So the answers will be 1 and 6. So I rewrite this like the following. 2x squared plus 1x plus 6x plus 3. I replace the 7x with 1x plus 6x. Now we do factoring by grouping. The first group has a GCF of x, leaves you with 2x plus 1 in parentheses. And the second group has a GCF of 3, which leaves you with 2x plus 1 in parentheses. The parentheses should match. Think about that as being your new greatest common factor. So you factor out the 2x plus 1. Everything left over, in this case x plus 3, comes in the second set of parentheses. Now what we're going to do is we're going to divide out the common factors. So we have x minus 4 divides out with x minus 4. And x plus 3 divides out with x plus 3. So for my final answer, I'm going to write 2x plus 1 times x plus 4. Over x plus 5. I'm going to leave it like that. I'm not going to multiply these together. You can. I'm just going to leave it like that. For the restrictions, again, don't forget about each of these. You have a restriction of 4. X cannot be 4. X cannot be negative 5. And x cannot be negative 3. I like to go smallest to biggest. So I'll say negative 5, negative 3, and 4. Again, because the denominator cannot equal 0. Example 3, multiply. The top left is the difference of two squares. So it'll be factored to become x plus 2 times x minus 2. The bottom left is also a difference of two squares. So that'll factor to become x plus 1 times x minus 1. Top right, you cannot factor. X plus 1, just leave it like that. Nothing to do there. And the bottom right has a GCF of x. That leaves you with x plus 2 in parentheses. Now let's divide out the common factors. Okay, so we have this x plus 2, it divides out with that x plus 2. And this x plus 1 divides out with that x plus 1. So what do we have left over? We have x minus 2 over x times x minus 1. You can leave it like that. For our restrictions, x cannot be -1. Again, if you're having trouble with the restrictions, okay, because these can give people trouble. Okay, again, what I'm doing is I'm taking each term, each factor from the denominator. In this case, this is an x plus 1. And I'm saying x plus 1 cannot equal 0. That means x cannot equal -1. X minus 1 cannot equal 0. So x cannot equal 1. X cannot be 0. That's easy. And x plus 2 cannot be 0. Solve that. You can probably do these in your head. But if not, this is what I'm doing. I like to put them from smallest to biggest. Okay. X cannot equal -2, -1, 0, or 1. Oops, that should be -2. I don't know why I put that. Hold on 1 second. Actually, you know what? Actually, I put that right. I don't know why. I don't know why I thought I did that wrong. That's good. Okay. So that was multiplying. And now the final 2 pages are going to be on dividing. Okay. So you can divide rational expressions. You can also divide rational expressions. Recall that to divide a fraction, you simply multiply by its reciprocal. So for example, if I said do 1/2 divided by 3/4, that's the same thing as doing 1/2 times the reciprocal of 3/4, which is 4/3. Now this is a little tricky though. When dividing rational expressions, you must state the restrictions for all the denominators used. That means the original denominators and the denominators after you change to multiplication by the reciprocal. Okay? If it's part of the denominator at any point, then it must be accounted for in the restrictions. Example 4, divide. State all restrictions for the variable. Okay. So first what I'm going to do is I'm just going to rewrite this as multiplication by the reciprocal. So x squared plus 2x minus 15 over x squared minus 16. I'm going to change this to multiplication times 3x minus 12 over x plus 1. Factoring the top left is easy. What two numbers multiply to -15 and add to 2? X plus 5 times x minus 3. The bottom left that's the difference of 2 squares, so x plus 4 times x minus 4. The top right has the GCF of 3. Leaves you with x minus 4 in parentheses. And the bottom right, you cannot factor. There's nothing to do there, so just leave that. Now divide out the common factors. There's not many. Just the x minus 4 is divided out. That's fine, though. So the final answer, 3. I'll put the 3 first so it looks nice. 3 times x plus 5 times x minus 3 over x plus 4 times x plus 1. Now we have to do the restrictions. Hold on 1 second. Okay, so here we go. Here's time for the restrictions. Okay, there's a bunch we have to worry about. Okay, so you have to worry about this. X plus 4 cannot be 0. So x cannot be -4. have to worry about this. X minus 4 cannot be 0. So x cannot be 4. You have to worry about this. X plus 1 cannot be 0. X cannot be negative 1. And remember, the original denominator was actually the 3 times the x minus 4. So you also have to worry about that restriction. 3 cannot be 0, that's fine. X minus 4 cannot be 0. But we redid that one, so we're fine. Okay? But don't forget, this was the original denominator. So you also have to worry about those restrictions. Okay? So final answer for the restrictions, x cannot equal negative 4, negative 1, or 4. Set, okay. One more problem. Oh boy. Okay, let me stop by just rewriting this again, and I'm going to change it to multiplication by the reciprocal. So x to the 4th power minus 9x squared over x squared minus 4x plus 3 times x squared minus 16 over x to the 4th power, getting ahead of myself right there, plus 2x cubed minus 8x squared. Okay, so factoring the top left, that has a GCF of x squared. It leaves you with x squared minus 9. We're going to have to factor that more in a minute, actually. Okay, the bottom left, what two numbers multiply to 3 and add to negative 4? X minus 3 times x minus 1. The top right, that's the difference of two squares. X plus 4 times x minus 4. Bottom right has a GCF of x squared. Factor that out, which leaves you with x squared plus 2x minus 8. And now you actually have to factor more, okay? So the top left in the parentheses, that's the difference of two squares. So x squared times x plus 3 times x minus 3. The bottom left can stay as is. The top right can stay as is. And the bottom right, the x squared stays, but in the parentheses, you have to factor what two numbers multiply to negative 4 and add to 2. I mean, what two numbers multiply to negative 8 and add to positive 2. X plus 4 times x minus 2. Now let's divide out the common factors, okay? This x squared can divide out with that x squared. This x minus 3 can divide out with that x minus 3. And this x plus 4 can divide out with that x plus 4. Hold on one second. And looks like that's it. Okay, so we have x plus 3 times x minus 4. Over x minus 1 times x minus 2. And now we're going to have to worry about the restrictions. So let's take care of that now. Okay, so you have to worry about the original denominator as well as your denominator right here. So again, you have to worry about a lot of restrictions here, okay? You have to worry about all the restrictions in the denominator. So all the restrictions right here, all the restrictions right here, and the restrictions up here in the top right, because that was your original denominator, okay? So I'll do it right here, okay? X minus 3 cannot be 0. So x cannot be 3. X minus 1 cannot be 0. X cannot be 1. X squared cannot be 0. That means X cannot be 0. X plus 4 cannot be 0. X cannot be negative 4. X minus 2 cannot be 0. X cannot be 2. And don't forget about the original denominator, which is right here. Okay, this was the original denominator. X plus 4 we already did down there. But X minus 4 also cannot be 0. So X cannot be 4. So we actually have all those restrictions. Okay. So it looks like we have 6 restrictions total. Hold on one second. Yeah, 6 restrictions. So hold on one second. Okay, so going in order, we have, I like to go smallest to biggest, so I'll say X cannot equal negative 4. Then we had 0, 1, 2, 3, 4. I'm just going to jot down one more note because this problem is, this is a little tricky. So don't forget to include restrictions for the original denominator also. Okay. So that is the end of that lesson, multiplying and dividing rational expressions.